Hey everyone, welcome to my channel. So I'm back with another ML project, and herein we are using deep learning. So I guess this is the first project wherein we are using deep learning. So I brought you a classification project and we'll be using images. So the goal of this project, it is to classify different types of fruits. I guess it's very obvious. Okay. Next thing that is very important for you to know before we move on is that we are going to use a pre-trained model which is called InceptionV3. So it's already trained on a very large data set. It's called ImageNet dataset. It's trained and it has all the information and all the weights in there. We are going to utilize that, and this term is usually called transfer learning. So yes, we are going to do transfer learning. We are going to repurpose this model for a new classification task. So instead of training from scratch, we fine tune the Inception V3 model by freezing most of its layer and then adding our own custom classification layers on the top of it. So this may sound really confusing or complex, if it might in the beginning. When we'll go through the code and we'll start coding, I think it might become easier. So we'll go step by step. So yes, let's go and look at our data set. So this is the Kaggle page of data set. You see that we have we have nine fruits, and we have 40 images or 40 files of each fruits. So we have around lot of data using images. So let's download these images and let's store it in Google Drive so that we can go ahead with our code.
So now let's open our Google Colab and we'll start coding right away. So I'll be creating a new notebook in the Drive. So new notebook in Drive. So we'll get a screen something like this. Let's start our code section. So let's now import libraries because we'll be needing them for our further part. So I'll start writing import important libraries. Then let's start by importing pandas. Import pandas as PD. We'll import numpy as np. I'll be importing cbon as sns, very standard codes guys, as sns. And then I'll import matplotlib.pyplot as plt. So these are standard libraries. They are used for data analysis and visualization. So pandas for tabular and numpy for numerical computation, etc. I'll be also importing OS, which is used for interacting with operating system like files and folders. I'll be also importing image from PIL. It will be used for working with images like opening and resizing. Moving on, let's import few libraries related to TensorFlow because we are going to take the pre-trained deep learning model from there. So we'll go step by step. I'll start first by writing all the libraries and then I can explain why I have taken what. So import TensorFlow as TF. Then from TensorFlow library, we're going to TensorFlow.keras dot models, import model and sequential. So model and sequential will be used for defining ML models. Layer, it is like it contains building blocks like dense, embedding, etc. Then we have Inception, which is a deep learning model which is pre-trained. It will be used for fine tuning. We have early stopping. It is used as a callback function to stop training early if validation performance stops improving. So now let's start with working with image data generator. So image data generator, it is used for augmenting and normalizing image data sets. Let's say that we have a certain set of images and we want to generate more of them by making few changes in them. It's called augmentation. And we also want to normalize them, normalizing in the sense that the pixel value starts for specific value, bringing them down to 0 and 1 so that our models perform better. Usually models perform better when they're rescaled and normalized. Okay, so now let's move on to specifying where our fruit data set is located. So I have actually put my data set in a Google Drive. So let's start by setting the path for that. So we can go at this side and we can mount our Google Drive. So all the drive folders and files will be displayed here. So you can go to whatever folder or path that you have saved. I have saved in YT, fruit classification and images. I'll be copying that path and I'll be pasting that here. So we have now the dataset path. Now we'll also specify some variables such as batch size, which will be which will be telling us the number of images that we want to process in one pass during the training. We also have variables for image dimensions like image height and image width. So these images will be resized and hence these variables. So I'm passing batch sizes 32 and I'll be resizing the pixels to 224. Now moving on to calling the image data generator function that we have imported above. So we'll be creating an image data generator which will be used for data augmentation and normalization. So let's start by creating our object. So train data gen equals to image data generator, and we'll be passing few variables or parameters, let's say. So one will be rescaling, which will rescale the pixel values from 0 to 255 to 0 and 1. So 1.0 divided by 255.0. Next we have validation spread, which will be using 20% of data for validation and rest will be used for training purposes. Moving on, as we already know that here images are rescaled and the data is split into training and validation. Now we'll start by loading these training data. So we'll be using a train generator variable and will the whatever object that we have created above train data gen dot will be using flow from directory function. It will be suggested here and we'll give some parameters. So first is directory. So okay, wait, that's why it's in caps. So we have directory, which will be the dataset path that we have defined above. So directory is dataset path. Let me write it down. Directory equals dataset path. Next we have a target size, which will be again the we have defined image height, comma image width. So image height, comma we have in suggestions, comma image width. Then we have other variables such as batch size, which is again equal to batch size. That's the name we have given above. We also have a class mode as categorical. Yeah, which will assume that the task involves multi-class classification as we have in this problem statement. Then we also give subset, which means this is set as the training data. So I'll be setting this as training. Setting as training data. Cool. Now moving on, we'll be doing the same stuff for validation data as well. So I'll be copying and pasting this below this and we'll be calling this validation. And I think rest of the things will be same. So let's just run this code. Let's go from starting. Oh, we have an error. It says cannot import name image from PIL. What's the error? Oh, I think the I is in small letter. It should be cap. So let's write it I as capital I. Yeah, let's start running again. Okay, successful. Now let's run this part and this part. Cool. So we have 22 images belonging to 9 classes. Then we have 70 images belonging to 9 classes. This is next one is for validation and the first one is for training data. Next what we'll do is we'll display information about dataset. So let's try to print some information. So print dataset information. So this is training samples and we'll be giving train generator dot samples. Yeah, same we can do for validation generator as well. So dot samples will give us how many samples for each uh, data we have. So validation samples, and we'll write here validation generator. Yeah. Next we'll be writing wait, we're not suggesting. Oh, I have used a train generator for both of them, so it's going to be validation generator for the second one. Cool. So now we'll not be seeing that yellow line. I'll rerun the codes now. Cool. Now moving on to, I'll be printing class indices. So let's write class indices, and we'll be using the train generator dot class indices. So it's also a function for that, class indices. Once I run the code, you will be able to see why I'm doing what I'm doing. Yeah. So we see that training samples we have 288, validation samples 71, and these are the indices. So let's say grapes fruit stands for 4, apple fruit is 0. So these are individual fruits that have each assigned an index so that it can be used for multi-classification. Now moving on to, let's display some images with their labels. So we'll be displaying some fruit images from our data set. So for this we are going to create a function. It's let's call it def get class label. So it will be a helper function for us in order to get the corresponding class name. So we'll be taking a parameter, an argument, we'll call it one hot encoded label. It will be kind of a vector, and we'll be assigning a variable which is called class index equals np max, and we'll be passing this label in here, vector, and we'll be returning a list. So let me just write the whole code first. This might because sound confusing and you might not understand, and then I'll explain it one by one each line. So this is the whole code that I'll be explaining. Let's first get into the first function part. So what we're doing and why we're doing. So here is a function breakdown. So let's say we have one hot encoded vector which is consists of 0 and 1. 1 indicates active class. So this np.argmax will return the highest value. So at index 2 we have 1, so the class index will be assigned 2. Now moving on, will we map the index to the class label. So suppose at 2 we have assigned a fruit, let's say chickoo. So this function train generator dot class indices, it is a dictionary created by Keras data, and it will map class name to numerical indices. So this way we get output as let's say if 2 is rabbit, so we get rabbit at that index. So this is basically the gist of the code that we have. If you go through it once more, I think you'll be able to understand it better. Moving on to a code for retrieving the batch of images and label, and then we'll display the first few images with the class label. So I'm running this data set. So let's just wait till it loads the images and prints it. Okay, it's taking quite a while. We'll wait. Okay, now we see. So corresponding to every fruit we have its name written beside that. So this is how it's done, and moving on. Now what I want to calculate is how our data set is distributed amongst the fruits. Fruits are distributed inside the training data. So we'll be calculating percentages of fruits, each fruits of training data. So I'll comment this line out, calculating percentage of fruits. For that, first let's find out the list of class indices and class labels. So we'll write class indices equals, that will get from train generator. We have dot class indices, we can call directly, so dot class indices, This will give us a list of class index. Then we'll also do class labels. What's the spelling of labels? LABELS, sorry. This will be getting through class indices dot keys. So this will provide the values, or the you can say values of this class indices, and will assign to class labels. So these two are the first few things that we need. Next, what we'll do is we'll count the number of samples in each class. So we want to calculate in each class how much we have, and then total how much we have. So I have written the whole code here because the code is very easy. We'll just have to go through them. So in the beginning, I'm iterating through the batch to calculate the number of samples. Then we create subplot, we create pie chart, we create the bar chart, and then just iterate and calculate. So it's a pretty easy thing. Okay, we have an error here. Okay, dot keys we have to you call this, so we'll use double bracket. I think we'll use parenthesis here. Yes, let's try running that again. So it's a very pretty simple code. I did not want to go one by one, so you can just look from like closely if you want to. So as we see, we have percentage distribution of fruits in the training data. So as we go down, we have a pie chart. We see that almost the class are evenly distributed, I'll say, more or less. We also see percentage of fruits, bar chart, I'll say. So this bar chart is done, pie chart is done. Now let's go to the main model part. So I guess you already know that we are going to use InceptionV3. So let's Google what exactly is. So I can see is that InceptionV3, it is a CNN, convolutional neural network, that is developed by Google, and it is 48 layers deep and has image input size of 299 by 299. Okay, we also see that yeah, it's a CNN that is 48 layers deep. Now let's go to ChatGPT and how can we use it. I think sometimes it's very convenient to use and see just to know how and abouts of this. So I'll just write how can I use Inception V3 in our classification model project. So for my classification TION classification model. So let's see. So it's saying it's a powerful CNN used for image classification. So first you import important libraries, then load the pre-trained model. So we see that we're creating a base model including top as false. Then what we do, we add custom classification layers. So if you want to add average, pooling and dropout and everything, you can do it there. Moving on, we'll compile the model using a loss function and optimizer. This part, which is pre-processing image data and generating batches of images, that is already done. If you remember, we have done it in the previous code as well. Then we'll train the model. So we'll do model.fit and pass the parameters. Fine tuning is optional. If you want to go ahead, you can fine tune the base layers. So we'll unfreeze the last few layers and compile again. So okay, so these are few steps that we'll be using in our code. So just to give a heads up into how we are going to use that. So moving on to the code, let's just load and fine tune our Inception v3 model. So first let's define base model equals Inception v3 that we have already imported above. Okay, we also have suggestions. So let's provide first weights. So weights, what it does is loads pre-trained weights from ImageNet, which is a very large image data set. So it will load the weights from there. Then we'll provide a parameter include top equals false. So it will remove the fully connected layers at the top. so that we can customize this model for our fruit classification task. We'll also provide the input shape that we have already defined above, and 3 because we have 3 color channels. Now let's just write x equals to base model dot output. So we have first initialize this. Now we'll add our customized layers. So first we'll do layers dot global average pooling, as it's already suggesting, the AI is already suggesting. So the global average pooling, what it will do is it will reduce the spatial dimension of the feature map, so it will make the model more efficient. We'll also use dense and layer, and we'll add a fully connected layer with 256 neuron and ReLU activation. We'll be also using dropout, which will drop 50% of the neurons randomly. Now we are going to store the values. It is the final output layer in predictions, and we'll pass num classes. So num class is neurons, and each neuron, it will represent a fruit class. And we are using softmax because it will ensure that the outputs are in the form of probability, so they are probability distributions. Okay, one more thing, we have used this model equals to model line. This what it will do is it will create a Keras model with InceptionV3 as base and our custom classification layers on top. Moving on, we'll freeze the most of the pre-trained layer because we'll select all except the last 20 rows, because we want that the early layers, it will capture general image features like edge and textures. So freezing early layers, it will speed up the training layers and prevents overfitting. That's why we have written layer dot trainable equals to false. So this is what we want to do using this line, the two lines. Moving on to compiling the model, so we'll write model dot compile. We'll pass an optimizer equals to we are going to use Adam optimizer, and with a very small learning rate, and we'll ensure that there is a gradual fine tuning. So I'll just edit here and use Adam. So tf.keras dot optimizers dot Adam will also add learning rate in bracket learning rate underscore rate 1e minus 4, so it's 0.0001 basically. So this is it. I think looks, and we'll add also matrix accuracy to track the model accuracy during the training. I'll also implement early stopping because this will help us not to overfit the data set. So when we realize that our validation accuracy is not improving over the time, we'll stop training our models at that point. So early stopping, okay, tab, and monitor is equal to, and we'll monitor validation loss here. We'll also provide val loss. We'll also provide a parameter patience, so it stops the training when validation does not improve for 5 consecutive epochs. And restore best weights, we have set to true because it rolls back to the best performing model weights. So this is what it we get from each parameter. Now we'll train the model, or basically fit our model. So we'll store it in a history variable model dot fit. Then we provide few parameters. First we provide train generator, which will supply the training images and labels. We'll provide epochs equals to let's just say 10. Then we provide validation data, which comes from validation generator, and callback we are giving as early stopping, which will enable the early stopping. I hope it's clear. Just write the comment, train the model. Next what we do is let's what can we do, let's just go ahead, let's print model dot summary. In order to print a summary of model, it will show us layer names, output shape, and number of trainable and non-trainable parameters. Moving on, we also want to visualize the training and validation performance, as I said. So what this will help us in plotting a graph, and we can see how over the time we are able to see the how the accuracy and validation accuracies and loss is going over the time. So the loss should decrease and validation accuracies should increase. So for that we'll write the code. Let's move on to the code. So we'll write plt. We have imported matplotlib, so plt.figure fig size. So we already see suggestions. I think we can go ahead with these. Looks right. Yes. plt dot legend. We also want the legend. Then also let's give the title, plt dot title, and I'll give training and validation accuracy as suggested. Okay. Now moving on to, okay, let's remove these two lines. Yes, same we are going to do for the loss. So plt dot subplot, and this will be the second subplot. So we'll write 1, 2 and 2. So first subplot, it will show training versus validation accuracy. Second subplot, which is 1 to 2, it will show training versus validation loss. And plt.plot history, it will plot the accuracy trends, and the second one will plot validation accuracy trend. So this is the whole code. Let's run through this. So before it runs, I want to summarize the whole thing for you. So what we do is we load the InceptionV3 model without the top classification layer. We add new layers for the fruit classification model. So we do pooling, we do dense, we do dropout, and then we do output. Then we freeze most layers to retrain the pre-trained knowledge. We compile the model with Adam optimizer, and we add categorical cross entropy loss. We also implement early stopping to prevent overfitting. We train the model with validation data and early stopping, and we display the training progress using model.summary, as we can see here. We also plot and accuracy and loss trains for training and validation. So this approach, it uses transfer learning to efficiently classify our fruits with high accuracy. So these are everything related to our model. If you have any further doubts and any questions that you want to ask or any help that you need, please go ahead and comment in the section below, and I'll be able to help you. As you can see in the graph, the accuracy is improving over the time and the validation loss is decreasing over the time. So yeah, this is it, and please like, comment and subscribe, and I'll see you guys in my next video. Bye.